Imagine walking into a casino. In front of you, there aren't just one or two, but 5 different slot machines. Let's call them bandits. Each machine gives you a random reward every time you pull the lever. But the catch is, each one has its own unknown probability distribution of rewards. Your mission, figure out which machine pays off the most in the long run. This is the essence of the K-Armed Bandit problem. It's a classic dilemma in reinforcement learning and decision-making under uncertainty. The challenge is called the exploration versus exploitation trade-off. Exploration means trying out different machines to gather information. Exploitation means using what you already know to maximize your reward. If you only explore, you waste time on bad machines. If you only exploit too soon, you might miss out on a machine that's actually better. So how do we balance the two? That's where strategies come in. One of the simplest and most popular strategies for solving the K-Armed Bandit problem is called the epsilon-greedy strategy. Here's how it works. First, we keep track of the estimated average reward of each machine as we play them. Most of the time, with probability 1 minus epsilon, we pick the machine that currently looks the best, the one with the highest estimated reward. But occasionally, with probability epsilon, we explore. We pick a machine at random, even if it doesn't look like the best one yet. This way, we get the best of both worlds. We exploit what we've learned so far, but we also keep exploring enough to avoid getting stuck with a machine that seems best, but really isn't. The value of epsilon controls the balance. A small epsilon means we mostly exploit, only exploring once in a while. A large epsilon means we explore more often, but might miss out on long-term rewards. Choosing the right epsilon depends on the problem you're solving. So when you start tackling bandit problems, the epsilon-greedy strategy is often your first tool. Simple, easy to understand, and surprisingly effective. That applies not only in theory, but in real-world challenges like online optimization, healthcare, and finance. If you enjoyed this breakdown of the K-Armed Bandit, make sure to hit like, subscribe, and drop a comment with the next algorithm you'd like me to cover. And remember, always explore a little, because that's how you discover the best rewards.